You know how fans spend months dissecting every leaked photo of a new kit, arguing over the team crest and the color choices? Honestly, it's kind of funny, because everyone is looking at the exact wrong thing. That jersey on the pitch? It's not just team merch. It is arguably the most advanced piece of tech a professional athlete owns. We're talking about millions of dollars spent just to hack air resistance. Today, we're pulling apart one of these things to see what goes on at the fiber level, because the engineering that makes a kit work is way crazier than any fan design debate. Let's start with the fast side of the kit: airflow management. When you run, you're pushing air out of the way. If your shirt is baggy, it catches that air like a parachute. That's drag. In a sport decided by milliseconds, drag is the enemy. Brands have essentially turned the kit into an aerodynamic tool. Look closely at the fabric weave. It isn't random. Engineers map the specific zones on the body where air hits the hardest, usually the chest and the front of the arms. In those areas, they use specific textures, tiny little patterns or ridges to trip the air. It sounds counterintuitive, right? Usually, you want things smooth, but in fluid dynamics, a little bit of texture can actually help air stick to the fabric longer, reducing the wake behind the player and making them move through the air more efficiently. It's the same basic principle engineers use on golf balls to make them fly further. Now that's the science of speed, but a fast player who is miserable, overheating and weighed down is a slow player by the 80-minute mark. And that's where the real complexity begins. If the efficiency side is about the air outside, the comfort side is about managing the engine inside, the player. A professional athlete in a high-intensity match can lose liters of sweat. If that moisture stays in the shirt, the jersey gets heavy, it sticks to the skin and it traps heat. This is where body mapping comes in. Engineers don't just use one type of fabric for the whole shirt. They use a system of different material zones. They'll put highly breathable, open mesh structures in the areas where you sweat the most, like the back, under the arms, and the sides. They'll use tighter, more durable weaves in areas that need protection or structural support. It's essentially a radiator system. The fabric is engineered to pull moisture from the skin to the surface of the shirt, where it can evaporate faster. They're constantly testing the wicking rate, how fast they can move water from point A to point B. The engineering genius isn't doing one or the other, it's doing both. If you make the fabric too breathable, it loses strength and gets snagged on players during a tackle. If you make it too aerodynamic, it doesn't breathe. These brands are playing a constant game of constrained optimization. How light can we make it before it tears? How much air can we let through before it loses its structural integrity? It's a design process that takes years of iteration, testing, and wind tunnel data, all condensed into a few ounces of polyester. So, the next time you see a kit release, don't just judge it on the colors. Look at the weave. Look at the patterns. You're looking at a system designed to cheat physics and keep a human engine running for 90 minutes straight. What other piece of everyday football gear do you think has a hidden engineering story? Drop a comment below and let's engineer an answer. And if you want to understand more about the hidden logic of the world around us, from stadiums to player movement, make sure to subscribe. And remember, there's always more beneath the surface.